this lesson is about a lab that students will do in this class. But it's more than just about the lab. There is also some theory and content knowledge work that students have to do. So before we do this lesson, you need to have watched the video. I hope you've done that already. I sent you guys a link to that already. And we're going to do a little activity now with some handouts that I gave you. Okay? So you have a handout that has these two molecules on them. Okay? You've got 4 of each of these. What these are the individual pieces of a polymer. Now, polymer means that you have many individual molecules that have been chemically linked together. Most of the time that's a covalent bond link, but sometimes it's not. Sometimes it's a hydrogen bond link, which we haven't even gotten to in this class yet. Sometimes it's an ionic bond link. But most of the time, and it will be today also, it's going to be a covalent bond link. So what's going to happen in these type of things is that you're going to have this particular one is going to be what's called a condensation polymerization. A condensation polymerization. And what that means is that some part of each molecule is going to be removed through a chemical process and form a product other than the one you're really looking for. And where that part is being removed then allows the 2 longer molecules to link together. Then those 2 molecules link to more and more and more, and pretty soon you get these really long strands of molecules, and that's what a polymer is. Now polymers are everywhere. You are mostly polymers except for the water in your body and your bones. Your hair is a polymer, your fingernails are polymers, your skin's a polymer, all your blood vessels are polymer, even the blood cells themselves are polymers. Okay, so it's these individual units linking together, and in your body they're called proteins. So the polymers are called proteins. Okay, so what happens is in this particular case, our condensation product is going to be hydrochloric acid, and it's going to come from a hydrogen and a chlorine, and they're basically going to leave. They're going to link up together to form hydrochloric acid, and then this part and this part, these 2 parts here are going to basically link together. Okay, and so when you do that, you get a longer chain. Okay, now this process continues. This link goes over on this end, and another one of these links goes over on this end. It just continues on and on and on ad infinitum. Okay, so what you have in front of you then are little pieces of paper with these molecular images on them, and what you're going to do is to take and rip away the necessary atoms from each of these and keep linking them together in that longer and longer process. Okay, so you're going to tear off something from here, tear off something from here, and basically just show how they stick together, and just keep on going. So you have 8 links. Now, just a couple of things about terminology. This is a monomer. This is a monomer. Together, when you put them together, they make a dimer. So monomer, put them together, you get a dimer. Okay, and when you get a long chain of these things, you get a polymer. Okay, now there's more than one kind of polymerization. This is called condensation polymerization. Everything we're going to be doing today is going to be condensation polymerization, where some smaller little product basically comes out and then the pieces link together. Okay, go ahead and get started with that. You need to clear your desk and start figuring out how to link your pieces of monomers together. As you link your molecules together, notice where the reaction is taking place. The answer is at the functional groups. Okay, so we've been learning about functional groups, and the reason for knowing about functional groups has everything to do with how the chemical reactions occur in organic chemistry. For the record, if you've been paying attention, I sent you this formal definition of a functional group. I told you yesterday a simplified sort of definition of a functional group. A functional group can be defined in a more formal way as a functional group is a portion of a molecule that is a recognizable, classified group of bound atoms. The functional group gives the molecule its properties. Functional groups are generally the locations on organic molecules where chemical reactions take place. And that last sentence is pretty much what I told you in class yesterday. So you're working on the first 6 questions alone. Then you're going to make a prediction down here, and I've marked them out on here because I don't want to advertise what it is that you're going to be doing in this class. Then you're going to do a collaboration down here, okay? The reason I have you do a collaboration is for 2 reasons. One, that that is how science gets done, okay? People don't work alone anymore, okay? But it's also true that, at the time that this class is going on anyway, just recently, Supreme Court Justice Scalia died. Y'all heard this in the news? Well, something else in the news is this person here, Ruth Bader Ginsburg, another Supreme Court Justice, they're always on opposite ends of things, okay? He's the conservative and she's the liberal on the court, or one of them anyway, and they're always at odds. But she and he are both very good friends, or were both very good friends before he died. And she said, by reading his opinions that the court writes about whether this should be the law, that should be the law, and his opinions being in opposition to hers, it sharpened her writing, it sharpened her thinking, and that's what happens. People are wired to work together to figure things out, okay? So when you have to figure things out together, you hear how one person explains it, you think about how you explain it, it sharpens and deepens how you understand it. Okay, so we're just about ready to do the lab. I have earlier classes leave their chemicals on the lab tables. All right, so what I want you to do, so that we don't use up unnecessary amounts of chemicals, try out what's there already, if there is anything there. And if it doesn't work, if you can't get the strands to pull up, as you saw how that's supposed to work, I hope you saw how it was supposed to work, then you can mix up some new chemicals, okay? We're going to have some waste. I'm just trying to reduce the amount of waste, all right? You need to finish and be back at your desk no later than 3:20, okay? 10 minutes before class is over. We got one more activity, and you need 10 minutes to get it done. If you're not back at your desk by 3:20, then you may not get the other activity done, and you just got to take the grade you get. So try to work diligently. Everybody in your lab group is going to make their own nylon, okay? So you got to have time for everybody to just wind the nylon onto a test tube or whatever you're using to wind it onto, okay? Any questions? Word of caution, the chemicals that you're using are pretty strong solvents. If you have fingernail polish on your fingers, it may take it off. Okay, if you are wearing clothing that's made of nylon, it might eat holes in it. So do wear your safety aprons. You should wear them every time anyway. Do wear your goggles. You should wear them every time anyway. And just be, judicious and careful with the chemicals. All right? All right. One other thing. Those disposable gloves back there, these chemicals will eat holes in that. So don't wear those gloves, okay? It takes special kind of chemical gloves for this, but really, if you get it on your hands, as long as you wipe it off reasonably quickly, it's not going to be a problem, okay? It'll dry your hands out, but it won't hurt you.